Hello, today we continue on with Chapter 9, Circles. This section is 9.4, Inscribed Angles. An inscribed angle has a vertex on the circle and sides that contains chords of the circle. In the circle below, angle ABC is an inscribed angle. Arc ADC is the arc intercepted by angle ABC. Vertex B is on the circle. AB and BC are chords of the circle. An intercepted arc has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. In circle C, minor arc AC intercepts by angle ABC. There are three ways that an angle can be inscribed in a circle. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of his intercepted arc. So the measure of angle 1 is equal to 1/2 the measure of arc AB. And the measure of arc AB is equal to 2 times the measure of angle 1. Example 1, find each measure. So if the measure of angle B is 36, the measure of arc AC is twice of that, 72 degrees. Letter B, the measure of angle N, if this arc is 62, the angle is half of this 62, 31. Letter C, the measure of arc QSR. If the angle is 113, the arc is double that, 226. 226. Letter D, the measure of angle R. We are looking at this circle. We have 120, 140 on these two arcs. So QS has to be 100. This angle then, X, the measure of angle R, will be 1/2 of this 100, or 50. Letter E, find the measure of arc MP. Find the measure of arc MP. If this is 31, this is 62. This is a diameter, PN, goes through the center. So if this is 62, MN, PM, arc MP, I should say, is 180 minus 62. Or 118. And that is example 1. Next page. Two inscribed angles that intercept the same arc of a circle are related. Two inscribed angles of a circle intercept the same arc. Okay, in this visual here, arc DA, we have inscribed angle C and inscribed angle over here, B. So what that means is if the two inscribed angles of the circle intercept the same arc or congruent arcs, then the angles are congruent. Okay, so these angles are going to be congruent. Angle B and angle C both intercept arc AD. So angle B is congruent to angle C. Example 2, find each measure. Find each measure. So we're looking for the measure of angle U. Okay, so angle U is right here. Okay, so if this is 30, okay, if this is 30 degrees here, this is also going to be 30 degrees. So you've got yourself this angle, and that angle also highlights that TW. So if this is 30, angle U is 30. Letter B, measure of angle T. Measure of angle T is 3x plus 4 degrees, which is also going to be equal to the measure of this angle W down here. So what that means is you're going to have 3x plus 4 equal to 2x plus 9. Okay, the algebra here, we're going to subtract 2x from both sides. You would have x plus 4 is equal to 9. Subtract 4 from both sides. X is equal to 5. So we're looking for the measure of angle T. Over here, the measure of angle T is 3x plus 4. So the measure of angle T, it will be 3x plus 4 x is 5. So we'll substitute 5 in for x. Thus, so the measure of angle T is 15 plus 4, which is 19. Example 3, find each measure. Measure of angle A. So we've got angle A, and let's take a look at angle A. Angle A is 6y minus 2. The other inscribed angle will be 5y plus 8. So 6y minus 2 is equal to 5y plus 8. 6y minus 2 is equal to 5y plus 8. And by doing this algebra, subtracting 5y from both sides of the equation, you have y minus 2 is equal to 8. Adding 2 to both sides, you have y is equal to 10. All right, so we're looking for the measure of angle A. So measure of angle A is 6y minus 2. So I'm going to take this 10, measure of angle A, and I'm going to take that 10 and I'll substitute it in for y. So 6 times the y minus 2. So I'll be 6 times 10. And then I'll subtract 2, and that will give me 58 for measure of angle A. Letter B, measure of angle C. The measure of angle C is 7x minus 11. And there's a relationship there with the 6x minus 3. So we have ourselves 6x minus 3 will be equal to 7x minus 11. This is the angle we're talking about, okay? These two angles have a relationship with the above theorem. Now, we're going to subtract 6x from the left and the right side of the equation, and that will give me x will give me the negative 3 is equal to x minus 11. By adding 11 to both sides, you have yourselves the value of x, which is 8. Okay, I'm going to add 11 to both sides, and that will be 8. So x is 8. Now, before you jump to the next work here, you want to look at what measure of angle C. So if you look at this measure of angle C, which is 7x, it's 7x minus 11. So we're going to take the 7, and then we're going to multiply it by that 8. And then we'll subtract 11. And that will put you at 56 minus 11. And so the measure of angle C will be 45. Okay, so keep a lookout for these types of questions. Dealing with two inscribed angles intercepting the same arc. Okay, so both of these angles intercepted this arc. Both of these angles intercepted this arc. Okay, another problem, example 4. In circle O, the measure of arc AB is 140. Let's put that in right away, 140. The measure of arc BC is 100. And the measure of AD is equal to the measure of DC. So AD is equal to DC. So AD, I'll call X, is equal to the measure of DC. And we'll call that also X. So they're the same, all right? So what we're put to task here, find the measure of the numbered angles, all right? So we've got ourselves 140, 100, X, and X. Okay, this doesn't look like it would be accurate, but before we go any further, let's find this little X here, and that will help us when we are answering these questions over here. Okay, so we've got a 360 degrees all the way around. So if I take an X and add another X, and then I'm going to add every single angle, 100 and 140. Okay, so we got 100 and 140, and that's going to equal 360. Okay, so the algebra here then would put you at 2x plus 240 is equal to 360. All right, now by subtracting the 240 from both sides, you're going to get 120 on the right. And on the left side of the equation, you're going to have 2x. So that puts that to be 60 degrees by dividing by 2. So by dividing by 2, you have yourselves x is 60. X is 60. Okay? So you want to get that work out of the way first on these problems. There'll be one right after this. So x is 60 here in this arc, and x is also 60 in this arc. All right, so now let's start the problem. Measure of angle 1. Well, if this is 60 here and it's at measure of angle 1, this will be 30. Measure of angle 2. Angle 2 is right here, which is across from this 60, so this will also be 30. Measure of angle 3. Measure of angle 3 is here. That's inscribing this 100, so this will be 50. Measure of angle 4. Measure of angle 4 corresponds to this 140. That will be 70. And that's example 4. Example 5 is very similar to example 4. Let's take a look. In circle F, the measure of WX is 20. So as I read this, I'll just kind of start putting some numbers down. 20. The measure of XY is 40. The measure of UZ is 108. UZ is 108. So all the way over here is 108. Okay, so that's 108. Then it says that the measure of UW and YZ are equal to each other. So again, we're going to call this X. We're going to call this X. Okay, so we have in the problem, back up a little bit, you can see that the measure of UW, which is right over here, is equal to the measure of YZ, which is over here on the right. So all the way around the circle now, I've got myself an algebra problem. Let's find out what X is first before we go any further. Okay, so that will help you when you do these types of problems. So we have X. So if I go all the way around the horn with this, I've got X plus 20 and 40, which is 60. Plus another X, plus 108. And what that's equal is 360. Okay, we have a little algebra here to do. So we have 2x plus 168, and that is going to be equal to 360. 360. Solve for x, subtracts 168 from the left side and the right side. And that puts you at 192 is equal to 2x. 192 is equal to 2 times x. So with dividing by 2 on both sides of this equation, you end up with x is 96. 96. 96. So we're going to go back up to our circle F here and put 96 in where these other spaces are. 96 is here, and 96 is here. Okay? So let's take a look at the measure of angle 1. The measure of angle 1 will be 1/2 of this arc here, which is, this is 96. So the measure of angle 1 will be 1/2 of that, 48. Angle 2. The measure of angle 2 is right here. And the opposite arc is 40. So the measure of angle 2 will be 1/2 of the 40, or 20. The measure of angle 3. The measure of angle 3 inscribes this arc, which is 108. So the measure of angle 3 will be 1/2 of 108, or 54. The measure of angle 4. The measure of angle 4 is this 20 plus 96, or 106. 106. So you've got yourselves 20 and 94 is 106. And the last one, measure of angle 5. Measure of angle 5, it'll be 1/2 of this 108, or 54. Okay, I want to make sure that we see this angle 4 again. So we have this angle 2. We found that to be 20. We found angle 3 as 54. So this angle 4 is not on the outside of the circle. So we have a 180 degrees, because it's a triangle there. And we're going to subtract 74. The angle 2 plus the angle 3. And that's going to get you 106. All right, next theorem. Theorem 9.8, triangles and quadrilaterals are inscribed in circles have special properties. An inscribed angle of a triangle intercepts a diameter, okay? Intercepts this diameter or semicircle if and only if the angle is a right angle. So in this example here, if arc FJH is a semicircle, FJH is a semicircle, then the measure of angle G is equal to 90 degrees. Then FJH is a semicircle and FH is a diameter. Example 6. Find the measure of angle B. Okay, here's the angle B. Okay, so since this angle C has this going, we're going to make that a right angle right off the bat. Okay, so it's going through the diameter, or it's the diameter going through the center. That's 90 degrees. So we have ourselves is the addition of x plus 4 plus 8x minus 4. That will equal 90 degrees. If I add this angle and this angle, that will equal 90 degrees. These 4's knock each other out, and these 8's combined like terms. 9x is 90, x is 10. X is, by dividing by 9, you have x equals 10. Okay, you want to find out what the measure of angle B is. So the measure of angle B will be equal to 8 times the x, which is 10, 10 minus 4. 8 times 10 is 80. 80 minus 4 is 76. The measure of angle B will be 76. Next example, we are looking for the value of x. Okay, we're looking for the value of x. We have two problems, value of x, and then we're looking for the measure of angle t. All right, so what we have here again is this inscribed angle encompasses that diameter, so we know that this is a right angle. Okay, so we're going to take 2x and we're going to add it to 4x minus 6. And that will be equal to 90 degrees. Again, because this triangle that's formed is a right triangle. And these two angles added together will equal 90 degrees. Okay, here's your algebra now. 6x minus the 6 is equal to 90 degrees, 90. Now we're going to add 6 to both sides. And that's going to put you at 6x is equal to 96. 96. And that appears that x is 16. By dividing by 6 on this side, on the left, and on the right, you have yourself x is 16. So if x is 16, we're going to ask ourselves for letter B, what's the measure of angle T? Angle T is 4x minus 6. And if we just found x to be 16, that will be 4 times 16 minus 6. So 4 times 16 is 64. And if I subtract 6, that is 58. And that will be the measure of angle T, 58 degrees. So keep a lookout for those types of problems. And lastly today, section 9.4, inscribed angles. We have a couple extra problems to do here. Let's take a look at them. We have one more theorem. That has to deal with quadrilateral. Okay, so while many different types of triangles, including right triangles, can be inscribed in a circle, only certain quadrilaterals can be inscribed in a circle. Okay, here's an example of it. Theorem 9.9. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so opposite angles are going to be added up to 180 degrees. So on this example here, if I was to mark this angle 1, and this is 2, and this is 3, and this is angle 4, what that's going to say is that measure of angle 1 plus the measure of angle 4 will equal 180 degrees. Likewise, if you take the measure of angle 3 and you add it to the measure of angle 2, got my little angle there, measure of angle 2, that will equal 180 degrees. So let's finish up with these two examples for today. Find each measure of angle S. We are looking for the measure of angle S. Okay. Angle S is 3x plus 5. Okay. So this is opposite that. You can have the U angle is 3x minus 5. So if I add these two angles together, they should equal 180. 3x plus 5 plus 3x minus 5 is equal to 180 degrees. Okay. All right, you can see these 5's cancel each other, and we have ourselves 6x is 180. By dividing by 6 on both sides, by dividing by 6, you have yourselves x is equal to 30 degrees, or 30, I should say. So the measure of angle S, it will be 3 times measure of angle S is going to be 3, here's the S, 3 times the 30 plus 5. That will be 95. So the measure of angle S is 95 degrees. 95 degrees. Measure of angle R. Okay, so we have 11y, and across from it we have 7y. So this 11y plus the 7y will equal 180. 11y plus 7y is 18y is equal to 180. Y is equal to 10. Okay, so if y is equal to 10, the measure of angle R will be 11 times 10. Which is equal to 110. Okay, so R is, a measure of angle R is 11 times 10, right here. So that this measure of angle R will be 110 degrees. And lastly today, section 9.4, inscribed angles. We have example 9. Find each measure. Okay. Measure of angle G. Okay, angle G is here. So we're going to start out with that one first. I will take this 8x plus 1, okay, and I am going to add it to 11x plus 8, and that will equal 180. So we'll start with that first. 8x plus 1 added to 11x plus 8, and that's going to equal 180. Okay, here's some algebra. 19x plus 9 equals 180. Now, let's subtract 9 from both sides. $19x will equal 171. by dividing by 19 on both sides, you will have x equal to 9. So for the measure of angle G, right here, 8x plus 1, we're going to take this 9, we're going to multiply it times 8. Then we're going to add 1 to it. This is 72 plus 1. That will put you at 73. So 73 degrees will be the measure of angle G. Measure of angle G. And the last one today, the measure of angle H. Measure of angle H. So what I'm going to do with H here, I've got the 6y minus the 4. Then we're going to add the 5y minus 3. So these are the two angles we're working with. Add the 5y minus 3, and that will equal 180. Okay, so that's going to put ourselves at 11y minus 11y minus 7, okay, is equal to 180. By adding 7 to both sides of the equation, you have 187 is equal to 11y. All right, finally, dividing by 11 on both sides, y is equal to 17. Okay, we're looking for the measure of angle H, which is 6 times the y. 6 times the y minus the 4 is angle H. So 6 times 17. 6 times the 17. And if I subtract the 4, I have 102 minus 4, which is equal to 98. And that concludes the lesson on section 9.4. Section 9.4. And section 9.4 is on inscribed angles. And hopefully it was beneficial for you. And if you have any questions, make sure you reach out to me. Have a great day.